And Schwarber sends one high and deep, way back, and this ball is long gone. Mercy. What in the world? Over the scoreboard on to Sheffield it goes. Schwarber with a booming home run, and the Cubs have a 6-4 lead.
So that was a great home run that you just watched by the Chicago Cubs. And when we're studying impulse and momentum, and you look at something like that, I want you to think about what changes the velocity of the ball. The ball was flying in toward the bat. It hit the bat. The bat actually compresses the ball momentarily, which you're going to see. And then the ball goes the other way. So what caused a change in the velocity of the ball? Hopefully you said the word force, that the batter had to apply a force to the ball using the bat. And when the batter does that and the ball compresses onto the bat and then flies away, it creates what we call an impulse. And an impulse is a force that's applied over a time period. So to actually calculate impulse, you would take the force that is applied to any object, and you would have to know the amount of time that that force was applied. That will tell you how much impulse was applied at that.
At 10,000 frames per second, we can see the regulation hardballs turn into squash balls.
That time. So I originally asked how the velocity changes, but how does the velocity change due to that applied force? What happens? It is definitely going to change due to the force that's applied. But let's look at where that comes from. So remember back to Newton's second law, force is mass times acceleration. We can do some substitutions here. I'm going to show you where we get the impulse-momentum relationship. So I'm going to derive that equation. If we go ahead and replace acceleration with the definition of acceleration, which is a change in velocity over a change in time, we get an equation that looks like this. And since we were just talking about applying forces over a time period, we're going to go ahead and put force and time on the same side of the equation. So I'm going to say force times a change in time is equal to mass times a change in velocity. This side over here is your impulse that you applied. If we're talking about a home run hitter in baseball, they apply a force over a given amount of time, and then something happens. You get a change in velocity. So how velocity changes due to the force applied is what we call momentum. And momentum is mass times a change in velocity. We note it with a P because we have run out of letters. We use M for so many other things that momentum we label with a lowercase p. So that is your equation for momentum. P is equal to M times V. Let's say we're talking about an object like hitting a baseball with a baseball bat. What if you were to increase the force? Then blank happens to the change in velocity. What happens if you increase the force to the velocity?
We say the impulse exerted on an object changes the momentum of the object. Ft equals delta mv is called the impulse-momentum relationship. Both impulse and momentum are vector quantities. Direction matters. We can apply this relationship to the unfortunate situation of being in a car that goes out of control and is brought to a halt by a collision. In any case, the impulse of the collision will bring your momentum to zero. Suppose the collision is with a haystack. Then the impulse, force times time, is mostly in time, which is a good thing. Note the long time means a small force for a given impulse. But suppose the collision is with a stone wall. Oops. Here the impulse is mostly force because the time during which the impulse occurs is short. Big Ft equals delta mv. So minimum force occurs when the time of contact is long. No matter how the car is stopped, the impulse Ft is the same.
Let's look at two spheres that are being dropped on a table. Let's imagine that they both fall with the same velocity and they both have the same mass. So watch what happens to the first one and then the second one. And so a good question might be, which has experienced the most dramatic change in momentum? It's kind of a trick question.